So what is this? Just for revision. What are these? Switches. Switches, which layer?
Layer 2.
Very good. Router is which
Layer
layer?
3. Layer 3.
Hub is which layer? What is hub? Hub is layer 1 device. Okay. First of all, they came with this hub, then switch, then router. They came. So because of add-on features. Okay. When comparing to hub and switch, what is the major difference? What is the major difference with hub and switch? Why they are not using today's networks? Why they are not using hub? Why they are using switch? Anyone can answer. Simple answer, one line sentence or one point you can add. What is the main advantage of switch? Why not hub? See, see the diagram. What it is saying. So hub is transferring the data to each and every one. Simple example, let's say you got your payslip, okay? So if you want, the HR is sending a payslip, okay, then your payslip will be seen by 2, 3, 4, 5. Each and every employee, if HR is sending payslip, everyone can see your payslip, or vice versa, okay? So if fifth one is receiving payslip, so 4, 3, 2, 1, everyone can see. It looks good actually. No, it doesn't look good actually. Okay. So whatever the information you are sharing, all the information will be seen by each and every person in the company. Okay. So unnecessary data is also going to each and everyone. Unnecessary traffic is also going to each and everyone. And on top of that, let's say this connection got disconnected. If one wants to send data to five, okay, it cannot send. So, and everyone also, their work will be disturbed. Okay, that is the main problem of the hub. What is not there in the hub? Security is not there, unnecessary traffic is going. Okay, all these things, confidential data is also going to each and every person. Okay, that is the problem of the switch. Let's say you have five people, you can manage that. Okay, some kind of tools are there, some you can you can do administration, you can manage. If you have 10 people, then also you can manage. Okay, somehow you will be, you one administrator, he can manage these things. But if your organization is going to 100, 200, 300 plus, then this kind of network we cannot use, because when the company is growing, their data and their security is very very important. You are getting clear? Okay. Then the next, what they have come across switch. They have invented switch based upon the hub. Okay, based on the hub and point to point. What is point to point? Only two systems how they are communicating. Then hub, then switch. So what is the biggest advantages they have brought in switch? They have identified what are the disadvantages are there in hub, so they overcome those things and they came. What are the problems in hub? Security is not there, data is sharing to everyone. And if one data wants to send, if one data needs to send to fifth person, two, three, four in between who are there, they are also has to receive the data. Okay, unnecessary data is going to each and everyone, unnecessary traffic. So to overcome this, they have come with the concept called switch. So these are the interfaces, and whatever the systems, let's say one system here, second system, third system, fourth system, five system, each and every system is connected to this interface. Correct? How many systems we can connect here? Here, how many systems we can connect?
Hub maximum 5 ports.
Right.
And we have
Ex-
48,
Correct.
48
Same.
ports.
Same. Let's say if I have 60 people, what I will do?
We'll
If I
use
have,
two switches and
we'll
we'll
use,
connect interconnect
yeah,
it.
yeah, we will use two switches. We can take this combination. Okay. Like, so this is layer 2. So now you got the advantage. What is the advantage? It is secured. So how switch will be maintaining? See the diagram. Yesterday we have already seen. So one wants to send data to 3. See, going yellow. So 5 wants to send data to 2. Okay, it is going. So it want 2 want to send data to 1. It is going to 2. It is highlighting C. 4 wants to send data to 3. It is going. Okay. Next, see which one is early. 2. 5. This is 5. 5 wants to send data to 2. So data is going to only, if I wants to send, what it is saying, I want to send data to only 2, it is going only to 2. 2 wants to send data to 1, it is only going to 1. How it is going? Any idea? Yesterday we discussed anything. With what help it is going?
MAC address.
Correct. MAC, with the help of MAC address and IP address. So how the system switch know this is the MAC address for this system? How switch is,
It will bind with IP MAC.
yeah, but where?
It's maintaining MAC table.
It's, yeah, switch is maintaining a table. So switch maintains a table. Let's say one table is there. Where is- Switch maintains a table. In the table, let's say I have 1.1, 1.2, 1.2, 1.3, 1.4, 1.5. These are the IPs of each and every laptop. Let's say these three laptops are Dell, these two laptops are HP. So what is the MAC ID? What is MAC ID? Where the MAC ID will be there? There is a NIC card. For inside the laptop, motherboard will be there. For motherboard, there is an add-on NIC card will be there. This is the NIC card. On that NIC card, MAC ID is binded. MAC ID. This is NIC card. NIC card is nothing but your LAN card, network interface card. Okay. So what is this MAC card? Example, simple thing I have said. Surname, your grandfather. Okay. Then son, surname, dot father. Then surname, dot son, surname, grandson, surname, dot daughter. So in this, what is common?
Surname is common.
Surname is common. So for this, each and everything, okay, LAN cards are common. And for, let's say I have a Dell laptop. Dell manufactures a NIC card. Okay, on that Dell manufactured NIC card. For NIC card, there is a MAC address. The MAC address first 8 digits are common. Then 4, 5, 6, 7 will come. Like that, Dell. I have one more laptop. So what it will come? First 8 digits are common. Next, it will 4, 5, 6, 8. Let's say HP. HP starts with first four letters 0. and first 444, then what it will come 1 2 3 4, like that it will come. So how, with the help of MAC address, what it will switch maintains, okay, this is 1.1 IP. Okay, let me make note of this 1.1, and its MAC ID is 111122224567. Similar way for 1.2. This is the IP address of this laptop, and this MAC ID is 111122224568. Okay, if there is 1.3 IP is assigned to third laptop or fourth laptop, let's say fourth laptop, I told HP. Okay, then it maintains, okay, this IP. Okay, this IP MAC address is 0000 4444 1234. It maintains. Now all laptops are connected to switch like this. Interfaces, two interfaces it is communicated. Now one wants to send data to 4. So what it will see, you are sending a message. First, where it will go? Via TCP communication LAN cable, it reaches the switch, and switch will receives request. Switch will be receiving a request. Then it will see, hi, what is your request? It will tell, I want to send data to 1.5. Okay, let me check whether I have 1.5 or not. So 1.4 or not. So here what it will do, it will check in this system 1.5 is there or not. So 1.5, there is a series of, okay, okay, give me your data. Whatever the data, whatever the packets is coming, it will take that packets and it will send only to whom? 1.5. That is the knowledge it is having. It will do this kind of things. So in between 1.2, 1.3, 1.4 is there. It is not sharing the data to these people. It is sending only data to 1.5, vice versa. Okay. Let's say now 1.4 wants to send data to 1.1. Okay. Then 1.4 will reach to the switch, and switch will listen. What is your request? It will see the request, what request I received. Then 1.4 is telling, I want to send communicate to 1.1. Then it will check who is 1.4. Okay, 1.4 is this one, and where he wants to send, he wants to send data to 1.1. Let me check 1.1 is there or not. It is there. Then what it will do, it will send to 1.1. Understand till here?
Yeah.
Yeah. So switch works on layer 2. This way it communicates. Okay. Layer 3. Layer 3 we discussed simply what networks. Let's say you have a 192 series of network, and we have 10 dot series network. These are different networks. So to communicate each other, the main IPs of these networks, we will put it in a router. So with the help of this router, okay, it will show you, okay, this it will help you to communicate each other, even though if you are in different networks. Did we discuss yesterday repeaters? We discussed, right?
Yeah.
Yeah. Okay.
Yes, sir.
Yeah. Now firewall. It is very important. Long back ago, now also this is very important. What is firewall? A firewall is one of the network equipment running on layer 4. See how simply they are coming. First layer 1, then layer 2, then layer 3, then layer 4, and slowly they are improving the technology also, features also. Okay, layer 4 according to the OSL layer. Okay, we'll discuss this word. A firewall is a vital to the network hardware located between the, where it is located between the internet, okay, which is considered an insecure network and the existing network. Okay, the task of the firewall, which is one of the basic network equipment necessary to ensure necessary to ensure the security of the network. Okay, you I will share this, you people read this, it will be very boring. I will tell you in easy way. Let's say now this is your internal network. Okay, it is here, your laptops are, you have connected in one room, you have connected here. Okay, then it is connected to switch. Then let's say if you have router, the router will be there. Okay, then here comes as a firewall. Correct or not? Simple network. Generally this is enough for any simple network, right? It is connected to this and this is connected to firewall, and then public internet. Very simple network, public internet. Now sim- let me tell you one thing. Now we are in cities. Okay, we are in apartments. Okay, we are in apartments. This is fifth floor, this is fourth floor, this is third floor, this is second floor, this is first floor. Okay, in every apartment we'll be having a security guard or not? We'll call as a security guard, we'll call as a watchman or someone. Okay, in general, what is the main responsibility of that security guy? Why this apartment, let's say this is 10 floors, 20 floors. Okay, so many families, 20 floors means 20 families are living, 10 floors means 10 families are living. That is, if it is increasing, we will put one more security guy. Let's say this is assume it is a gated community. Then what we will do, we will hire security guards, four security guards, because this is a gated community expanded. Okay, assume like anything, it is apartment, it is a gated community, whatever. Okay, gated community, apartment, anything. Okay, if number of people are increasing, then we will increase security guards also. Reason? Why? Reason?
One security guard can't manage many of them.
Yeah, main entrance or at the borders of your building, we will be placing the security guards. Okay, why? It's for one security. What security? Okay, let's say these 10 floors, 10 people, 10 families, this security guy, this security guy knows. Okay, this is the main entrance. Okay, if anyone is coming inside the house, this security guy already know these 10 families, then he will allow those people to go inside. Okay, now one of the second floor, some relatives are coming. Okay, relatives are coming, they are coming. And what will happen, this security guy will stop him here at the entrance. What he will do, he will ask, started questioning, who are you, where are you from, to whom you want to meet, why you came here. Okay, then other side people will respond, we are relatives of second floor of some so and so, and we are here to visit their home. Okay, then what generally this security guy will do, he has to call these people, or these people has to inform him earlier, vice versa can happen. And then the security guard, what he will do, once he got the confirmation from the second floor family, then he will allow this relatives. Nowadays we are having delivery boys, Zomato boys, Swiggy boys, courier boys. Okay, some other people, unknown people, sales boys, marketing boys. Okay, unknown people, so many people are coming and advertising. But is it very good to allow each and every unknown person inside your apartment, inside your gated community?
No,
It is not good, it is not safety. We don't know, a robbery person also can come inside and can do robbery. Okay, anybody, if you are allowing anyone inside, then it's a risk is there. People can come, delivery boy can come, courier boy can come, Swiggy, anybody can come, but it risk is there. So that to avoid that risk, okay, we cannot completely always remember in your life, nobody can 100% avoid risk. A risk should be accepted, at least 80% you can cure, rest 20% you have to accept. Even though you are a security engineer, even though what level you are, top level in security or anything, yeah, risk is always there. 100% risk cannot be resolved, okay, at least 90-80% you can resolve, rest 10% you have to accept this. So instead of, there is one Zomato guy, one courier boy is coming, so this boy will stop him and he will ask each and every unknown stranger, and he will stop and he will ask, he will make a note and he will get a confirmation, then only he has to send. That is general scenario, okay. If you follow like this, it is very well and good, okay. Now all of a sudden there is a robbery team, we'll call as a Cheddi gang. In, I don't know whether other people know or don't know. In Andhra Pradesh, these people nowadays are very famous. Okay, there is a Chetty gang. What they are doing? They are coming in the night times. Okay, they are coming inside and they are doing a robbery and they are going. So let's say there is a people of five people of this team are there. So what police people will do? Who will come into the picture? Police people will come and they are putting photos, and they are circulating these five people photos to each and every area, each and every individual house, each and every apartment. Okay. So what security guy will do? He will maintain security guy room is there na, he will paste these five photos in his room, and he will recognize whenever these people are coming, he can recognize because he police people has given those photos. Okay, now let's say one of the robbery guy from Chetty gang is coming inside and he is telling, I am a delivery boy. Okay, so with this information, will the security guy will allow this person or will not allow? He will recognize, he will not recognize?
He will recognize.
He will recognize. That is one kind of security the government has given to the police department. So because this is creating a problem, so they are sharing each and every information to in each and individual houses for every Indian citizen who is residing, especially in these areas where it is they are impacting. Okay, so with this, what he will do? He will stop and he will not allow this guy, and he will do argument with this guy and he will send back him. Okay, if if it is a gated community, all the four security guys will have this information of these five people, and they will be alert and they will not allow this guy. So if known person is coming, he can go. Unknown person, it will not allow. Let's say this person doesn't have the information, and whether this person is telling, I am a courier boy, I came here. Okay, so somehow he will manage, he can enter inside. All of a sudden, the security guy trying to call these people, your bad luck, the second floor people went outside. What will happen? He will go inside, he will tell, I will put the luggage here and I will come back, like that he will tell. Then he will tell, okay, okay, why to take risk? He will go inside and he will start doing robbery. This can also happen. If you have information, you are okay. If you doesn't have information, then it's a problem. Same scenario for your organization. Who will do all these things?
Firewall.
Cyber admin, or for normal thing, system admin, we'll call as a cyber admin, or a sim administrator. Threat hunter, he is the guy. Threat hunter, he has to create those policies, or sim admin can implement that policies. Okay, so threat hunter or other team I told, right? Purple team. We are belongs to which team? Blue team. And there is one more team called red team, and this is purple team. Purple team is the one team who who creates the policies. These are the policy makers, okay, for each and company. So these are the laptops. They will create a policy. Nobody should access pen drives. Nobody should access Google Drives. Nobody should not send their personal data, okay, or download personal data into your laptops. Nobody are not supposed to send any confidential data to your Google Drives, to your personal drives. So how those are the who are defining those rules? This legacy audit team, okay, compliance team. These people are defining the rules, and these people are implementing it. You're understanding here? Who these are? The policy makers. They will create policies for the company to make our company secure. Once they create policy, that policy implementation, who will be doing? Technical team will be implementing those policies. They are applying group policies. You know group policy? Group policy is nothing but set of policies are applied on the companies. Okay, so now where I am, okay, the it is connected to switch. Then switch is connected to router is connected to firewall. So in firewall we will write a rules, incoming and outgoing rules, and outgoing rules. Same example of this apartment. If known person only can come inside, unknown person not supposed to come inside. Okay, if let's say I allow 1.1 1.4, these two people only supposed to go outside, rest three people are not supposed to go outside. Then if 1.2 is trying to go outside, what firewall will do? It will check the rule. First, what firewall will check, what firewall will be having? Firewall will be having a set of rules, okay. What rules? Incoming and outgoing rules, okay. Which ports and protocols, which port and protocol should I go outside, which ports and protocol should come inside. I will tell you what is port and what is protocol. First listen. Same this scenario you implement here. I told 1.1 can go to outside, 1.4 can go outside. Rest of the people are not supposed to go from inside to outside. Now 1.2 is trying to go outside. Will the firewall allow him to go outside or not? It will not give permission to go outside, because it will check the rule in firewall, okay, and it will stop this 1.1. You are not supposed to go outside of the network. Please go back. And 1.1 is coming and it want to go outside, okay. And what firewall will do? It will check the rule, okay. In outgoing rules, 1.1 is allowed. Then what it will come? It will go and talk to the internet. Whatever the information is required, it will take and it will come inside. Generally laptop will not go, that communication will happen. I will discuss in later in DNS class. I will tell you in detail. As of now, you understand this scenario, okay. You're understanding this now?
Yes.
Yeah, everyone is accessing Google. Whether you are getting Google page or not, everyone is getting Google. So Google belongs to your company? No, Google belongs to some other company which is outside, which is not in your network. But you people are accessing Google page every day. How this Google page is coming? Google page, it is a public. Google IP is public IP is, let's say 202.202.202.202. Okay, so this is public IP, okay. When you're trying to access Google page, that firewall will check what IP is requesting, okay. We have DMZ server also. Instead of you, the DMZ server I will tell you, okay. Then it will check what is the request. It will check each and everything. Then what will happen? 202. So in your firewall, 20 it, this is outside now. In outgoing, it will see whether Google public IP is allowed to inside my network or not. So it is allowed. So what it will come, it will come inside your network and it will give you Google page, because it is allowed. Firewall is allowing you. Okay, whatever the request whatever the request you are asking, it is checking and it is going outside, and whatever the page is coming, the response is coming. Okay, the whatever the request you ask, the response come and giving. Simple example, there is a small family, father, mother, and two kids. Okay, so mother is a housewife. Okay, she is not a working woman. In this scenario, one of the kid is asking, "Papa, I need Kinder Joy." So father, what he will do? Who will go outside? Only father will go outside. Father will go outside. Whatever the request his daughter or his son is asking, he will only go outside and he go to the shop and he will bring that Kinder Joy and he will come inside and he will give it to the his kid. So her wife is asking, I need some vegetables to get. Okay, who will go? He will only go outside and he will bring the vegetables and he will give the he will fulfill her request. The same scenario here also it will apply. You understand this scenario or not? Okay, let's say you have grandfather also, he is 70 plus, he is not able to walk. Okay, he needs some medicines. So let's say that time father is not there, so father is outside, he will make a call, and what he will do, he will bring the medicines for you. Who is doing most of the things here? Father is the responsible guy, he is the main pillar of the house. If no other persons are earning persons, then he will take the responsibility. Whatever the requests are coming from these people, he will take that request and he will see whether he can fulfill the request or not. Then what he will do, if he can fulfill the request, he will bring those things and he will fulfill your whatever the things you are asking. Same way, firewall, it is acting like your father, your head of this company. Okay, it will check which packet is allowed, which packet is not allowed. He will tell all those things. If they are asking unnecessary things, what father will tell? No, I am not supposed to give that item. No restriction, like that. Till now, understood? Any confusion?
Yeah.
It's clear now. Pala, Satya, Prasad, Glenn, Prasad, Punita, Glenn.
It's clear.
It's clear.
Clear.
You people are understanding what I'm saying, na? There is no confusion in my teaching, right? You are understanding.
No, it's clear, Abhi.
Okay, good. Okay, not this page. Where I am? Firewall. No quiz. Okay, I will. Quiz is like the first device in layer 2 only delivers the incoming packet to the destination connected to its related port. But why? Okay, why to confuse you? I will ask later. Okay. Okay. Anybody having idea on DNS? Anybody? People worked in earlier DNS? Okay. So anyway, you people know I'm not explaining much. Okay. This is a network card. Have you seen physically this network card?
Yeah.
Right. So generally, if you have CPUs, if you have laptops, now nanotechnology is coming. Before this much add-on card, we will what we will call in olden days. This is called nano. Sorry, this is called add-on card. Add-on card means with motherboard it will not come. So we have to insert this. See, this is the insert button. See, these are two lines are there. we have to insert this in on the motherboard. On the motherboard, this slot we have to insert. This is PCI slot will be there. So one PCI slot will be there like this. Let's say you have a motherboard like this, and there are PCI slots are there, and there is one cut here, one more cut here. This LAN card they will be inserting here. So this will be showing outside of your system like NIC card, something like this. So you are putting the LAN cable, inserting LAN cable like this. These are add-on cards, and these are PCI slots. We will be calling as a PCI slots. Okay, additional. Now nanotechnology is coming within inside your laptop. They are inserting this. Okay, so this is the LAN card, and this is the Ethernet port, and this is the PCI connection. Okay, so every NIC card, what we will be having, see, MAC address. We will see how the MAC address is coming like this. So whenever a manufacturer, whether it is a Dell, whether it is a Intel, whether it is a Lenovo, some other third party company, HP, okay, what they are doing, they are manufacturing this motherboard, and they are manufacturing this network card, and what they are doing, they are binding one MAC ID for each and every network card. Let's say they have manufactured 1,000 cards. Okay, for 1,000 cards, the manufacturing MAC ID will be different. It will be same. It will be 66 only. No, it has to be unique for each and network card. Why? Because it has to communicate each and every person. That is the concept. What is the network card concept? Each and every system will be having different network card, so each can communicate to each other. Let's say you have a family, and you family, okay, for father and mother, they have a 4 kids. For 4 kids, they will put the same name. They will not put the same name to the 4 kids. They will put different names. If they put same name, if they call Satya, all 4 people will say yes. If I put some different names to 4 people, 4 kids, and if I call only Satya only will listen. Okay, so the similar way, why they are putting unique to each and every network card. If I'm calling to network card 1, and if there is network card 2, there is network card 3. If I'm calling only network card 3, this will only respond. That's the reason, for each and every card, MAC ID is very important. MAC ID is different for each and every network card. So the MAC address is 6 byte, okay, 48-bit long, and is expressed as a hexadecimal. Okay, the address below is an example of MAC address. See, first 8 digits will be common, then it will be changing. This is sorry, here they are telling the first 3 bytes of the MAC address is obtained from the relevant organization. These three, not four. These three are relevant from the organizations. Who are they? Vendors. So, as per the industry standard, who are manufacturing these NIC cards, first three things should be common. So with this three, it will come to know this card manufactured by Dell, this card is manufactured by Intel, this card is manufactured by some other vendor. With that, you will come to know. Then the last 3 bytes are determined by the vendor. Okay, the last three will be determined by the vendor. In this way, each MAC address become a unique one. So they can communicate if different MAC addresses are there, network are there. These are the systems. Okay, then they are connecting to the switch. So each magnet is unique. Then one can communicate to three can communicate to two, because their names are different. This is network card. This is MAC ID. Okay, any doubts? It is clear, right? Simple. See, now if you want to go, you can go and search this website, and you can see which vendor is having MAC address. How this, let's say this is Microsoft Corporation. Their first three are like this, rest it will be changed. Now if you have a MAC address of HP or Lenovo, You go this to website and see, only type the MAC address, they will give the name of the vendor. Okay, this is the web address, macaddress.io. You can just type in your laptop get mac. The command is get mac, get mac. You will get the mac address. Paste in this website, you will get that mac address which vendor has manufactured it. Okay, so this is the command. You can put ipconfig also, ipconfig/host. Will what it will show? What is the host name? What is the node? And IP routing enabled, wins, DNS, and here comes your MAC address. See, this is the MAC address. You copy this MAC address and use that link, and you will come to know who has manufactured this NIC card, displaying the MAC address. If config. If it is a Linux machine, you have to use if config. Okay. If it is a Windows machine, you have to use IP config. Only P or F is common for Linux. It is F, for Windows it is P. Very simple. VPN will discuss tomorrow. Any doubts still here? See, now I showed you, right? Switch will be maintained a table like this. See, switch lookup table, Ethernet frame. Okay, this is switch, and this is Ethernets are nothing but your NIC cards. Okay, device A, this MAC address is assigned. Device B, this MAC address is assigned. C, this MAC address is assigned. D, this MAC address is assigned. So it will be maintaining all this simple. Okay, if you want to communicate, it will see the source and destination. Source IP is 6C. Where is 6C? Here, 6C. 6C wants to communicate to whom? 56. It will, with the help of this table, it will communicate like this. It will maintain this table. See, it is pinging and data is going, and switch is seeing to whom I need to send, and it is reaching to the destination to whom it was. ARP also we will discuss. I will not confuse you with ARP now. I will discuss ARP. But in the background, this is your infrastructure. This is your architecture. See, these are the switches. Switch 1, switch 2, switch 3, switch 4. Okay. Like this, they are showing. And whenever you are giving ping, just you are pinging 1.3, and how it is checking. This is from here you are sitting, this is a triple A 1.1 is pinging 1. It is going and it is checking where is 1.3, 1.3, and the packet is going and it is reaching PC3 1.1.3. Ping request is going from 1.1. This is 1.1. Ping request is in, you have in 1.1 in your laptop you have opened 1.3 is alive or not. Okay, then you are pinging. What it is saying, it is checking, it is not going to here and here, it is reaching here and it is sending, okay, 1.3 is alive, and then whatever the data you are transferring, it will transfer. So what is ping? What is ping? Pocket Internet Gopher. What it will do, it will see whether the systems are live or dead. With ping request, what we are getting, if I am talking to you, you are listening to me. If I am silence, you feel something odd, whether I am there or not. The same way, the system will check whatever the systems they are. First, what they will do, they are doing ping to check whether system is alive or dead. So if you are getting a response from 1.3, then what it will do, okay, the system is alive, so I can send data. So in small infrastructure, let's say you have 5 people, this architecture is more than enough, right? You are having 2 systems and you are connecting to switch, and you are having a router and you are connected to internet, correct or not?
Yes.
The same way, if your network is increasing, this only you bit expand and you put securities, firewall, one more firewall will come, correct or not? The same way. Okay, and you started defining rules in firewall. Firewall, what firewall will see? The main thing firewall will see incoming and outgoing, and what port need to be enabled and what port not to be enabled, and what are the port protocols are allowed, which are denied. All these things predefined switch will not identify. As an administrator, as a firewall administrator, you have to tell the firewall, you have to create a rule, and you have to apply, you have to put it in the firewall. Then only firewall, if anything is coming, any request is coming, then firewall will check the whatever the rules we define, it will check that rules and it will follow those rules. It doesn't analyze, it cannot analyze on its own. Whatever you say, that only it will follow. In your apartment, you flat owners, 10 flats are there, flat owners, they will be having a meeting, and they will they will have some discussion, and they will tell whoever the delivery boy, zomato boy, courier boy are coming, they should give those couriers to the security guy only, they are not supposed to come inside. If this is the rule, then security guy will not allow those persons inside, he will only collect, and security guy only come inside and they will give it to you. Some apartments they will tell, okay, first take the information and then call us, then and then you send that boy. That is one more rule. Like that, in your firewall, who are defining the rules? The firewall administrator has to define the rules, which packet should come inside, which packet can go outside. Those are the rules defined by the firewall administrator. Then firewall will follow those rules and check whether this port, let's say 53, port 53 or port 21, port 80, is allowed in my firewall or not. If it is allowed, it will allow. If it is denied, it will drop that packet and it will tell you are not supposed to go outside based on the rules you define. So what is IP address? Structure of IP address. So IPv4. Why we are getting IPv4? Those are the ARPA. Those are the defense team. That is a big story. They have invented. They used in a defense first of all. Okay. Then slowly they started exposing it to the internet. Okay. So how this started? You can search in internet how internet started. It's a very interesting story. Okay. So what is IP address? IP address is the ID of the device network address. Connection operations are performed using IP address. IP address are divided into IPv4 and IPv6. Nowadays, we are not everyone, but major companies are using IPv6. Example of both types of IP addresses are the following. Okay, this is 192.168.4.1. Now IPv6 is like this. It is very difficult to remember. At least IPv4 we can remember, but this is very difficult to remember. Okay, this is also one kind of security. Okay, but one thing, the IPv4 got exhausted, so they come up with a concept called IPv6. The structure of IP address. The IP address, this is the IP address, consists of what? 4 bytes. This is 1 byte, this is 1 byte, this is 1 byte, and this is 1 byte. Okay, you have a 5 star chocolate or your dairy milk, and the dairy milk you are divided into 4 parts, and you are, let's say you have a 4 kids, you are giving this each bite to 4 kids. The same way we are segmenting the network. Okay, IP addresses into different networks. Okay, so this is IP, internet protocol, internet whatever I forgot that. Okay, that is divided into 4 bytes. Okay, and each byte consists of how many octets? 4 octets. These are 4 octets. Okay, a period is placed between each byte and is expressed in decimal, 8 bits. These are called bits, bits, bits. For anything, it is an algorithm in computer, algorithm, binary system only, right? Zero ones are there in the background. Okay, each byte is having 4 bits. Okay, A period is placed between each byte and is expressed in decimal notation. For example, the image below shows the conversation of the IP address. So tomorrow we'll discuss how this 10 came, how this 5 came, how this 37 came, how this 156 came. Even though these are not required, but if you have this knowledge, it is very, very good. You will feel comfortable. Okay, we'll discuss how this is converted into like this, and this is converted to like this, and how this 10 came like this. Tomorrow I will discuss. Okay, any doubts still here, everyone?
It's clear.
It's clear. Tomorrow we'll divide segmentation, then tomorrow we'll start DNS, everything.